Dear students, welcome to this video number 3 on simultaneous fault. In this video, we shall have some numerical on two-port network. So I will take the first example. I will take first example on Z parameters. Okay, so let us take example number 1. Find Z parameters Okay, so I will take a circuit. Say the value is R. So this value is also R. Now this circuit, why I have taken it as an example 1? Because this is an can regarded as a basic building block for of the circuit for finding Z parameters. Okay, and I am taking the examples which are asked in the university exam papers. So I am not considering the examples which are there in the course of electrical circuit analysis. I am taking very simple examples over here which are asked in the SUK question papers. So now this is the network given for which we have to find the Z parameters. Okay, and this you can take it as a basic building block for finding of the network for finding Z parameters. We will understand it. Now let us have input voltage V1. I1 is the current, input port current. I2 is the output port current, and V2 is the output voltage. Okay. Now how we can find Z parameters? So there are many ways as such. One, it is analytical. One procedure, it is analytical. Second one, it's a practical way. You can have numerical approach. Okay, I will use analytical approach here for finding Z parameters of this circuit. So what is analytical approach? In the analytical approach, we write set of equations. So KVL and KCL, and after writing these equations, we manipulate so as to bring it into the standard equation of Z parameters. Now, what is standard equation for Z parameter? We know that is V1 is equal to Z11I1 plus Z12 I2 V2 is equal to Z21 I1 plus Z22, that is I2. So this is the equations of Z parameters. So what is done in analytical approach, KVL equations or maybe also KCL equations, they are written for the given circuit, and that equations they are rearranged or manipulated so as to bring it to this standard form. Then from that equation, by comparison, we will find this, we can get this Z parameters. Let us see how we can do it for this circuit. Now here we have two loops, so this is loop 1. So let us take this loop current as I1, and this is loop 2. Let us take this current I2. So now the current that is flowing in this resistor, it will be I1 plus I2, the sum of two loop currents. Now we can write the equation. So what KVL equation? Let us write to KVL equation to loop 1. Now V1, that voltage, whatever it is we applied here, this is equal to the drop here in this resistor. The drop is I1 into R. I1 is the current that flows and R is the resistor, voltage drop. Similarly, the voltage drop over here, it is I1 plus I2 into R. So it will be, I will write here I1 plus I2 into R. So these two voltages, I1R plus I1 plus I2R, will be equal to V1. So we can write in KVL like this: I1R plus I1 plus I2 into R. So rearranging, we can have the equations as another 15 minutes making one video. So you will have this rearranging this 2R into I1 plus R into I2. So let this equation be 1, that is V1. Now let us write KVL to before that. Now if you compare this equation with our standard equation, what we have written, that for Z parameters, we will get, so we can see this Z11, it is equal to 2R, and Z12, it is equal to R. Okay, now let us write KVL equation to loop loop 2. We get V2 equal to, now here we will have a voltage drop plus and minus I2 into R. Positive polarity will be where the current enters. Okay, so now V2 will be equal to the total voltage drop I2 R plus I1 plus I2 into R. So we get this as R I1 plus 2R I2 which is equal to V2. Now if you compare this equation with our second equation, standard equation, then we will get the value as Z21 equal to R and Z22 it is equal to 2R. Okay, so this is how we can find the Z parameters for the given circuit using analytical approach. I will not discuss here numerical approach because this is not a dedicated course on electrical circuit analysis. Now let us go to another example. Example number 2. Now let us find Z parameters for this circuit. Okay, now let us take all values as R ohm. Okay, let the voltage here be V1, let I1 be the current, let V2 be the voltage plus and minus, and I2 be the current. So this is plus or minus voltage. Now this question has been asked in one of the university question paper. Now if you refer back, one important aspect here we have to understand here. What is that? So I will write this equation in the matrix form as V1, V2, it is equal to here we have I1 and I2. So, okay. So this equation now Z11 is 2R. So I can write here 2R. This is Z11 parameter. Then I have Z12R. Then R, Z21 and again 2R, Z22. So this is Z11. This is Z12, this is Z21 and this is Z22. Now how I can get this equation? How I get these values? If you directly from this network. So if you just see here R plus R, how you can find Z11? Z11 is equal to this resistor plus this resistor. So R plus R, it will be 2R. And what is Z12? How you find Z12? Z12, it is equal to the resistor which is common. So this resistor R, it is common for loop 1 and 2. So you can take it as value R. Similarly, Z21, you can take this resistor R. The value of this resistor is R. Then Z22, it is equal to this resistor plus this resistor. So it is 2R. So what is the point here? If your network is of this type, suppose if I give you one circuit like this, suppose this is 1 ohm, this is 2 ohm and this is 3 ohm. Then what will be value of your Z11? Z11 will be equal to 1, this 1 plus 2, it is 3 ohm. This is 1 plus 2, 3 ohm. What is Z12? Z12 value will be 2 ohm. Z21 value will be 2 ohm and Z22 value will be 2 plus 3, it is 5. So this way, if your circuit is in this form, then we can directly write this Z matrix or Z parameters with just looking at the circuit. So this is the same approach what I am going to now use it here. Now I want, first what I will do, I will try to bring this circuit into this form. Because if I can bring this circuit into this form, then I know that Z11 is this resistor, this is say R1 and this is say R2 and this is say R3. Then what is Z11? Z11 will be equal to R1 plus R2. Z12, it is equal to R2. Z21 will be also equal to R2. Z22 will be R2 plus R2. So now the question is how I can bring this circuit to this one. So what we will do, now this resistor, this, this, this one and this one, they are connected in star. So let us convert this into equivalent star like this. Okay, so let this value be Rx or say R1, R2. Okay, I will take Rx better. Rx, Ry, and Rc. So what will be the value of Rx? Rx will be equal to, what is the value of Rx? Rx is equal to this resistor into this resistor. This is R into R divided by sum of the three resistors. So R plus R plus R. Well, I will just show you. Suppose now your, this is your delta connection. What we have, I just show you. This is R value. This is R value. This is R value, and you are going to find this Rx. Now what is Rx? Rx is equal to this resistor into this resistor. So what it is in the numerator. In the denominator, sum of the three resistors R plus R plus R will give you this. So this is R square divided by 3R. So it is equal to R by. Similarly, what will be the value of Ry? Ry will be, now this is what we are taking it as Ry over here. So what is Ry? Ry is equal to this resistor into this resistor. So R into R divided by sum of three resistors. So it is 3R. So this is again equal to R by 2. Similarly, your Rz will be also R by 3. So this Rz, it will be also R by 3. So now how your circuit will look like when you convert this delta to star? Your circuit will look like something. This is R resistor, and then we have R by 3. This is Rx. What I am writing here, Rx is equal to R by 3. Then we will have Ry, which is equal to R by 3. Then we will have one more R, and here this is Rz, which is equal to R by 3. So your circuit will become like this. Now this is your R1 value. So what is R1 value? R1 value, R1 will be equal to R plus these two resistors, they are in series, so it is equal to 4R by 3. Okay, then R2 value is R by 3. Okay, this is R2 value, what I am taking. R2 is R by 3. And what is R3? R3 value, the value of this value, it is sum of these two resistors. So it is again 4R by 3. So once you have these values, now we have find out what is R1 value. R1 is 4R by 3. R2 is R by 3. R3 is 4R by 3. Then what is value of Z11? Z11 is equal to, already we determine R1 plus R2. So R1 plus R2, R1 value is 4R by 3 plus R2 value is R by 3. So it is 5R by 3. What is Z12? Z12 is R2 value, which is R by 3 only, R by 3. What is Z21? Z21, it is equal to R2. R2 value is R by 3. Then Z22, which is equal to again 5R by 3, which is R2 plus R2. So this is how we can find the value of Z parameters. Now here I have not applied any, and I have not written any KVL equations, but I have used the knowledge of the basic building block. So this is our basic building block. So if you have, if you any circuit, if you could reduce to this form, then Z parameters can be directly determined. Okay, so this is what the problem. Now suppose for the same network, if they ask Y parameters, if they ask Y, so I will do it in the next class. Otherwise, suppose for that same network, if they ask Y parameters, then what you can do, Y parameters is Y is equal to Z inverse. Y is equal to Z inverse. So I will just show you. Suppose for the same network, if they ask you Y parameters, what is Y parameter? Y is equal to Z inverse. So already we find Z matrix, Z parameter. So Z11 is 5R by 3. This is R by 3. This is R by 3. This is 5R by 3. So how we can find the inverse of this matrix? So I will give you just one example. Suppose if I have a matrix A, which is equal to A, B, C, D, and I want to find the inverse. So how we can find A inverse? A inverse you can find it by simple, just interchange this principal diagonal element D, bring it here, A you bring it here, just interchange this, and then you put a minus sign to off diagonal element, minus B, right, minus C, then divide it by the determinant of this matrix. What is determinant? Determinant is A into D minus B into C. This is how we can find the inverse. So now I want to find the inverse of this matrix, Z inverse on the same background. So what you can do, now first you interchange this. So if you interchange, it will be same, not change 5R by 3, 5R by 3, and then put minus sign to off diagonal. So I put minus sign. Then divide it by the determinant of this matrix. What is determinant? This into this. So it will be 25 R square divided by 9 minus r square divided by 9. So now it will become like this. So it will be uh, 5r by 3 minus r by 3 minus r by 3, 5r by 3 divided by 24 r square divided by 9. So now what will be your Z11? Z11 value, sorry, this is Y11 value. Now Y11, what is Y11? So Y11 value will be equal to, uh, so now you can bring it, so I will take this inside the matrix. So this is 5r by 3. This will be 1 divided by, so it is 9. If you, yeah, this is 24 r square minus r by 3 minus r by 3, 5r by 3. Now if you bring this into the bracket, then what will be this value? What this value will be 5r by 3 into 9 divided by 24 r square. So this will get cancelled. So this value will be, so you will get this value as in the bracket, I think 5 r divided by 8. Similarly, if you multiply this, I will multiply it out here, r by 3 into 9 by 24 r square is 3. So you will have 1 divided by 8r. So you will have, sorry, this not will be here, this is r will be over here down, then this will be 1 by 8r. Here also you will have minus 1 by 8r, and here it will be same value 5 by 8r. So this will be your y parameter matrix. Okay. So in the exam, if they ask you y parameter for the same circuit, don't adopt this procedure. I'm just telling you, if you know z parameters, in the case, suppose for this circuit you know z parameters, and you know how to find z parameters, but they have asked y parameters, then you can use this. This is one of the approach. Okay, otherwise directly y parameters can be find out for this circuit. So we will see how to find y parameters in the next class. Thank you very much.